So let's consider inverse proportion. So the way this works is we have a cause that leads to an effect. But in this case, if the cause increases, the effect decreases. So an example of this might be food and hunger. Let's say you have this feeling of hunger. The more food you eat, the less hungry you're going to be. So the more you eat, the effect is the feeling of hunger decreases. Now, you could have something else like this. If something decreases, the effect increases. This is also inverse proportion. So, for example, excuse me, suppose you are waiting to see a movie. You've got to wait 3 hours. But as the waiting time's getting shorter and shorter, the excitement about the movie's getting more and more. So as the waiting time decreases, it goes from 3 hours to 2 hours to 1 hour to 10 minutes. The excitement increases. So this is inverse proportion. So let's do an example. And there are certain situations that lend themselves to this. One of them is pressure and volume. Now, the idea here is if you have a volume, you can kind of experience this. If you put some air in your cheeks, and then if you squeeze, I'm careful, you don't want to hurt yourself, but I can feel the pressure build inside my mouth as I squeeze on my cheeks when they're full of air. And that means I'm shrinking the volume that causes the pressure to increase. So if we have volume, there's a relationship between volume and pressure. As the volume decreases, the pressure's increasing. Likewise, if I am squeezing my mouth full of air and then stop squeezing, let my cheeks relax so they can expand, the pressure goes away. So as the volume increases, the pressure decreases. So this is an inverse relationship. So suppose someone gives us this problem. Suppose there's a volume of 100 cubic centimeters, and this has a pressure of, let's say, 20 psi. There's some kind of gas that has this property. What is the pressure for a volume of 50 cubic centimeters? Now, PSI is a measure of pressure. So at 100 cubic centimeters, the pressure is 20 PSI. So what would happen if we shrunk this volume down? What would the pressure be? Well, we want to first recognize this is an inverse relationship. So how do we set those up? Well, you have a C1, a cause leading to an effect, and second cause leading to second effect. So the way we set these up is the following. The C1 goes here, the E1 goes below and across. The C2 goes here, and the E2 goes above and across. And so this is how we set up an inverse proportion. So for us, we could say 100 cubic centimeters results in a pressure of 20 psi. And then 50 cubic centimeters, well, we don't know what that pressure is going to be, so we'll call it a variable P. So this is our C1 and E1. So we'll put 100 here, 20 here. This is our C2 and our E2, which we don't know. But that's how we set it up. Cross multiply. We'll get 50p equals 100 times 20, or I should say 50 times p, or 50p equals 2,000. Divide both sides by 50. We get P is equal to 40. And since this is a pressure, it's going to be PSI. And that's how you work with inverse proportion. So any questions about that? Let me know.